Welcome students. In this video we are going to see about serial communication. To establish a serial communication between the PC and Arduino Uno. So this is the objective. We want to send a number like 7 or some number from PC to the Arduino through RS-232 and display that received number in Arduino Uno using a some segment display. This 7 segment display we have done in the previous experiment, so you can make a duplication of this 7 segment display circuit and you can make this modification for this. So now getting into the actual code, we will see some uh, introduction to this serial communication. Before, what is this communication? What is communication in embedded system means? Transfer of data between one device to the another device. The device can be uh, either a sensor or a microcontroller or a actuator uh, or other modules, hardware modules. Transferring data from one to the another is the communication. This communication can be of two types. One is parallel, another one is serial. Parallel is like I have two devices. This devices, if I want to transfer 8-bit information, D0 to D7, the data lines were connected between the two devices, device 1, okay. The 8-bit data is connected between the two devices and one common clock is connected. So what it means is whenever the clock is triggered, at that time the data will be transmitted from device 1 to device 2 or device 2 to device 1. So the information exchange will happen only in this trigger point. So at one trigger itself, 8-bit information is transferred. But for example, let us take a PC over here and printer over here. This is a this is a earlier parallel port in the earlier PC were used for mostly printers. Okay, so that I gave this example, and here one for one clock pulse, one 8-bit information is transferred. Since the printer is going to be at the side of the PC, so there is no problem. But if the devices were kept apart in a for a long distance, more than 100 meters around like that, then what is the problem? The problem is here we have to install lot of wires and maintain those things, so that results in installation cost and maintenance cost. So that what they did is they went to the serial communication. In serial communication, basically there will be two wires. One is transmit wire and another one is receive. In transmit, receive, and a common ground. So this is an example for RS-232 only. It's a asynchronous transfer, and in this asynchronous transfer, whatever the data this device 1 have to transmit will be sent through this TX pin, and it will be received in the device 2 in the RX pin. And the same way, TX pin in the device 2 will transmit the data, and RX in the device 1 will receive the data. So this, now here you can see the number of wires were reduced and the installation and the maintenance were reduced here. So that is the advantage of serial communication. Here in serial communication we have a lot of other protocols, not only RS-232, there are a lot of other protocols. Example is starting from RS-232, I2C, SPI, CAN, LIN, given USB or few serial communication protocols. Here, mostly widely, this RS-232 is called as serial port because it is the initial serial communication protocol developed, and so it is called as serial port widely. Any microcontroller, any development board which refer to serial communication, serial port, then it refers to RS-232 protocol. So in this RS-232 protocol, what is the it is a what is there? Okay, it is a asynchronous mode of transmission. Okay, what is asynchronous mode of transmission and the opposite synchronous mode of transmission is, let us see the synchronous mode. Here I have data to be transmitted or received, and clock. Here the data is common, so if the device 1 want to transmit a data, it drops the data over here in this line and shares the clock in what rate, where is in what bit rate the data has been transmitted, that has been shared over here, that clock is given. So for each clock pulse, it will trigger the device to receive one bit information. So this is synchronized way. Okay, we have learned this digital also. You have flip flop, and all the flip flop shares one common clock. Then it is synchronized. If they are not sharing a common clock, then it is asynchronous. The same way you can understand this. So if there is a common clock between the devices, then it is a synchronous communication mode. Okay, if there is no common clock, then it is a asynchronous mode. So here you can see this, there is no clock signal shared between these two devices, so that's it's called as asynchronous. So then how do they distinguish the bits, how they understand which is the starting and ending of a bit or information? It is done using uh, synchronizing bits called start and stop. So let us see that in detail. So I have a TX pin and here RX pin. When this transmitter want to transmit a data, it will by default this transmitter will be in a high logic. It will be maintained in logic 5 or 5 volt. Okay, whenever it wants to start communication, what it will do is it will pull this transmit signal to low, and it will keep it low for a certain time, and after that it will start communicating the device, start communicating the data, and again it will pull it down to the 0, sorry, again it will pull it up to logic 1, the ideal state, until the next transmission begins. So from here, this is start, and this duration is, and after that ideal continues. So between this, the data is being transmitted like 1 0 1 0 1 1 0, like that. 8-bit information is being transmitted. So here we use this start and stop bit for synchronizing the transmitter and receiver. So whenever the start comes, the receiver will wake up and start listening and start receiving this serial bits into the buffer, and when the stop bit comes, it will stop the reception. So this way 8-bit information is transferred between the two devices. So at what speed these devices were communicating, for that both for that what what is important is both devices should the serial port of both devices should operate in the same speed, and for that we have to configure the both devices in the serial communication in a particular standard baud rate. Okay, there are a lot of range like 2 I think, and 9600 and 11500. These are few standard baud rate of serial communication. Okay, this is the default baud rate. Okay, by default, most of the devices will operate in this baud rate. So if you don't know the baud rate of some device, you can set to this baud rate and try establishing a communication with that device. Now, so baud rate is uh, rate of change of information in the serial port per second, or it's referred in bits per second. Based on this few information, we are going to write the program now. Here we have this third experiment, that is interfacing a 7-segment display with the Arduino Uno. The same thing we are going to use, and we are going to modify the code accordingly. So what is the modification we are going to do is, we are going to add just few lines of program. Okay. So what are the things we have to perform in serial communication if we want to program it? First is initialization of serial. So here what we are going to do is, we are going to say at what baud rate this serial communication is going to work. So we are going to initialize it as 9600 baud rate. So this is the first step and first thing we have to do. And next is transmit data and receive data. Transmit data and receive data. For this we have the corresponding functions are there. Okay, for transmit data, that we have to we will go to the code. So these three things are there for serial communication: initializing the serial port, transmitting the data, receiving the data are the three parts of the serial communication. Now here we are going. Now here we are going to see that what are the functions involved in it. So to initialize a serial port, we use serial.begin and the baud rate as a parameter passed to this function. So if you write this port will be configured to operate in 9600 baud rate, and uh, here it will wait for the serial to be initialized completely. And here now serial dot println, and in this the string which we want to send is been written over here. This is for transmitting a data. Okay, so here we initialized and we transmit. So this two functions uh, uh, keep it in mind. And to receive a data, this is the way to receive a data. So wait for serial interrupt or serial data to be received, and this is a function which returns the value serial dot read brackets. This will return the value of what is the data serially received data will be returned by this function. So that value is assigned to count, and that has been printed again. So now you may ask, what is this 48 is for? 48 minus 48 is to convert the ASCII value to the decimal value. So ASCII value and decimal value, what is the difference? So now here you can see, if I transmit some value like 3, okay, it will be converted into ASCII, American Standard Code of Information Interchange. this format it will be converted. What is this format? This number 3 will be converted as or stored as 33 in hexadecimal. Okay, this 33 in hexadecimal will be transmitted from the laptop to the Arduino Uno. So the Arduino Uno, whatever it receives is will be in ASCII code. So I have to convert it back to the uh, decimal format. So this is the chart, like 30 is for number 0, 31 is everything in hexadecimal, 31 is for 1, 32 is for 2, 32 is for 2, 33 for 3, 34 for 4 and goes on, 39 for 9. So the numbers, numerics were mapped in this way for a ASCII code in hexadecimal format. So in order to retrieve the actual number, what we can do, we can subtract this 30. If you 30 minus 30 hexa, it will return you the actual number. 31 minus 30 hexa will return 1. 32 minus 30 will return 2. 33 minus 30 will return 3. So this is a simple idea to convert from ASCII to decimal. So here 30 we have to subtract. So if you see 30 in hexadecimal, if you represent in decimal format, it is 48. So that's why we are subtracting by 48 here. Instead of representing it in 30 hexa, we are representing it with uh, in the decimal format, that is 48. So that so for example, if I have typed 7 and transmitted number, so it will be received as 37. 37 minus 30 will give 7. So this 7 will be stored in this count register, and here what we are doing is just for an echo purpose, for understanding the data is properly received or not. So I am just sending the same value echoing back to the PC. So the 7 it will print. So print is transmission of data. So read is for RX, and the same way print is for transmission. So Arduino will transmit this 7 to the PC, and it will display that number in the terminal of the PC. In PC we have tools like putty or comport, like that terminal windows are there to establish serial communication with the target device. Even Arduino IDE itself has a one serial monitor. So that serial monitor is given in this simulator here. So it is in the bottom of this code section. Okay, when you have to go to the code section, in code section you will find it in the bottom, serial monitor. Here you have to type the number what you want to transmit and send. So you can see that number is displayed over here. Okay, whatever that has been displayed over this box is from Arduino Uno. Okay, whatever the information is over here is being transmitted by the Arduino Uno. Okay, now so what happens here? Now after the initialization of serial port, we give a welcome note. That welcome note is displayed in the laptop. Okay, this is displayed in the laptop, and after that it goes to the loop, and here what it does is it waits for the serial data to be received. So once I type 5, until I type 5, it waits over this line number 152. Okay, and it waits there. When I type 5 and send, it transmits the data. Here from the PC to the Arduino, it is being transmitted. So once it is transmitted, the Arduino receives the data and converts it to the decimal value and prints it in the or echoes back to the desktop or laptop. So that's why I have received 5 over here. Whatever the data I transmitted, I received it back over here. And after this, the loop will be again the program will be looping again to this loop function. Here when it comes to the switch case, which we have written for one segment, will switch to the case 5. In case 5, we have made the pattern to make the number 5 to be displayed. So, and the number 5 is displayed over here. And if I want 7 again, you can see that number 7 is being displayed over here. So, this way you can, uh, it's just to make you understand these three statements: initialization, data transmission, and data reception. Okay, these three important things are the key point or take home point for today's lab. Other things are already done. This sound segment display interface and all already done. So these three parts are the important thing, and underlying mechanism also we have learned today. That's all for today's lab.